For 10 years, I've been making eggs for breakfast. And for 10 years, I have been annoyed. I always get egg on my fingers. So I go wash them off, grab the next egg, and do it again. Ugh. Which drives me absolutely crazy. I've been fantasizing for years about some kind of tool that would cleanly crack an egg for me. So I decided to make my own, thinking, how hard could it be? Turns out, very, very hard is the answer. I was thinking this would be a pretty simple mechanism, but one thing led to another, and I basically ended up designing a mechanical computer, which of course was very hard to get working. And since every failure basically meant exploding an egg in my shop, it wasn't very fun to test, and the smell, ugh.
And after all that, my wife wasn't nearly as impressed as she should have been.
It's huge. It's complicated. It's ugly.
But they say you can't make an omelet without breaking a few eggs, or in my case, a few pallets of eggs. So come watch me go from youthful optimist to mature pessimist as I try to solve one of the trickiest kitchen tasks. I want this to be a handheld thing that I could actually use in a kitchen. So no electronics, no software, no 500-pound milling machine, no lasers. Handheld, compact, purely mechanical, and I think I have an idea for how I could do this. Eggshells are brittle. If you stress them beyond a certain point, they just crack, which reminds me of a cool thing about glass. If you scratch it and then crack it, the crack tends to follow the scratch. And I'm wondering if we could do the same thing with an egg. Put a scratch around it where we want it to break, and then start a crack, and hopefully split the egg in half. It's actually kind of hard to make a scratch on an egg that goes all the way back around to where it started.
So, I really hope this doesn't blow up in my lathe.
That would have been a lot easier if I hadn't glued the egg in with an inch of runout, but we have a decent scratch. Let's see if we can get it to crack. Yeah, it totally split right along the crack. And it hasn't just split in half because there's still that membrane on the inside holding it together. So to actually crack it, we're gonna have to hold it on both sides and hopefully tear it. Oh man, I crunched it. But the side that didn't get crushed looks great. Nice clean break. I think this is really promising and we can make a device that does this. Scratch the egg, crack it, dump the contents. Let's go make an egg cracker.
I'm imagining a handheld tool that kind of looks like this. It would hold the egg from both sides with some kind of gripper that can spin it, and then it would have a cutting head with a little knife to scratch the egg, and then a hammer to hit that scratch and crack it. After that, the grippers would pivot down to tear the membrane and dump the egg. And we don't want egg on our fingers, so they also have to eject the shell. And I want this easy to use, so all of this will happen when you turn a crank.
And it's the crank that makes this crazy. Like, how do you scribe, and then hammer, and then dump, and then eject, just by turning a crank? It's gonna be bad, but we have to put a pin in that thought because there's a riskier problem we have to solve first, which is holding the eggs.
We have to hold the sloped end of an egg, which is gonna wanna just pop right out of the gripper. And then there's a lot of variation in the shape and size of eggs, and whatever I come up with has to be able to hold them all.
I spent a really long time trying to figure this out. I considered everything from spikes to glues to suction cups.
But I have an idea that just might work, so let's see. So this is a mold that's 3D printed. I'm using it to cast silicone around a 3D printed part, which is surprisingly easy to do. You inject the liquid rubber, wait a few hours, and then you have your part. This is called overmolding.
The egg just slides in like this, and it basically palms the egg and holds it really well. And the stretchy silicone can expand to accommodate pretty much any egg size. One of the tricky things about making something like this is that the silicone doesn't really bond to the plastic. So we had to make a special shape within the hub that the silicone will mold around and get physically trapped so that they can't come apart. And then after the egg has been cracked, there's a built-in spring-loaded ejector that can eject the shell. That was close. And then, oh, having too much fun. So I want to test these to make sure they work before we build anything else. I'm going to scratch and crack it by hand. Then we're going to see if we can split the membrane with these, which I think is the hardest part.
So if I put the other gripper on here and twist, it should split.
It's not even close. Man, that membrane is strong. Ugh, I thought this was going to work for sure. I tried a bunch of different rubbers, from really soft and grippy ones to stiffer ones that'll grab the egg tighter. Nothing is working. So fundamentally, the problem seems to be that they can stretch this way, which limits how much torque they can apply to the egg. So we don't want it to stretch this way, but we want it to stretch in this direction so that we can still get eggs into it. And I think it should be pretty easy to do. This is the new hub for our egg gripper. It has these tethers built into it, which are really flexible in this direction, but they're really strong in this direction. They don't stretch at all. And the silicone gripper is cast around these tethers. This is a partial pour, so we can kind of get a cross-section view of what's going on. The little T-shaped ends of these keys into the rubber. It makes it really strong in this direction. If you try to pull on it, it doesn't stretch at all. But their flexibility still lets the rubber stretch outward so we can get an egg in there. This holds the egg 100 times better. Here's one of the old ones. So I'm just gonna manually score and fracture the eggshell and see if these grippers can pull it apart. Oh gosh. Yes! I knew it! You just have to hold the egg right. We can finally hold the egg. Now we have to make everything else. And what we're gonna have to do, I think, is work backwards from the egg grippers to everything else because these are sort of set in stone.
Which means we need to figure out the main body and crank.
When you're trying to figure out how to even do something, it makes it 10 times harder to only have a tiny bit of space to do the thing in that you don't even know how to do. Every time I've ever made something handheld, I've said, I'm never doing that again. And then I do it again. These are some of the most complicated parts I think I've ever had to design. And it's for a stupid egg cracker. But I think I have something that might work. So let's get them made and find out.
3D printing is always my preference because it's so easy to do. And thankfully I've been able to use it for most of the parts. There are a few select machine parts, but they're all pretty simple. And here it is all together. Doesn't really do anything yet, but we're getting there. This is the crank that's going to drive everything, and it spins the egg through a series of drive shafts and bevel gears. And then to split the egg and dump it out, the egg grippers can pivot down like this. And they're spring loaded against a hard stop, so they always return to the starting position. And to make them pivot, you pull on this cord, which is routed around a pulley that's integrated into the pivoting part. The cord isn't connected to anything yet, but the plan is to make a mechanism that will pull on this at the right time. And this side pivots on the drive shaft. It's kind of a 2-for-1 special, which I hope doesn't come back to bite me later. And there's a critical detail here. The drive shaft has to be designed to rotate this way. If it rotates this way, its torque will also make the egg gripper pivot down, which is no good. And then we also have the eggshell ejectors. The ejectors are a spring-loaded shaft that goes through the drive shaft and is held back with a little latch, which releases it when you push it up. But the latch isn't going to release itself. We need something to trigger it when the time is right. But it's tricky because they're inside this rotating gearbox, and running another mechanism through this pivot would be a nightmare. So I designed the egg dumping to have 2 positions. The first would dump the eggs, then we'll rotate even further, which lifts up the latch with a little ramp, releasing the ejectors. And even this was tough to fit in here. And then the last detail is this side slides back and forth so we can fit all the different sizes of eggs. Now that we can spin the egg, we need the thing that scratches and cracks the shell. I'm imagining a sort of floating head with a tiny knife that can cut into it. And then next to that, we'll have a spring-loaded metal rod, which can hammer on the scratch to crack it. And here's what it actually looks like. This cutting head is tiny. It was a challenge to fit all this in here, but we got it done.
So let's go do some 5-axis machining.
Parts like this cutting head make me so thankful to have a 5-axis mill. It has holes and features on every side that are off-axis, and a lot of stuff isn't even square. And the 5-axis can rotate the part to all the different orientations and machine it all in one shot. Well, except for that tab on the bottom, but we don't talk about that. And so much for everything being 3D printed. This used pretty much all of my tools. Even some weird ones.
This tiny little part on the end of all this is the cutting head. It is so tiny. And ultimately it's gonna mount on the main drive shaft, floating above the egg like that.
And this is the cutting blade. It goes in like this so that we can tune how deep it cuts and try different blades. The cutting head will contact the egg right about here. Getting the shape of this dialed in so that it could cut all the different shapes of eggs was really challenging. And then this is the hammer. It's a metal rod with a rounded tip that's spring-loaded. It's positioned to hit exactly on the scratch made by the cutting blade, and this spinning cam lifts and drops it. The main drive shaft will go through here, and as it turns, it'll spin the cam with this belt. Although this means the hammer will always be hammering, and I'm worried that might cause issues. So I'm going to also have a little pivoting latch, which will catch the hammer in the pulled back position. But if you push the latch out of the way, then the hammer's free to hammer as much as it wants to hammer. This gives us a simple way to turn the hammer on and off by pushing and pulling on a rod with some other part of the mechanism.
So I was just looking at this and I realized I'm an idiot, unfortunately. So I designed everything for the hand crank to be turned this way.
But that'll just jam up the hammer.
I even had an item in my to-do list to check that everything was turning the right direction, and I checked it off. It's gonna take a bit of hacking.
This ended up being less bad than I was expecting. I just stuck another gear in there and it reversed everything.
I don't think I've ever had a literal Uno Reverso card work before. Awesome. At this point, this thing has all the hardware that it needs to crack an egg, but if I turn the handle, it'll just spin the egg forever. And that's because there's nothing in here to actually make it do all the different functions in the right order. So we basically need to program it, but we don't have a computer in it, so we're gonna have to do it mechanically.
Imagine connecting our main crankshaft to another shaft with a very weird set of gears that look like this. Every rotation of the crankshaft will make this gear move through a set of distinct positions. I'm going to call this the program wheel, because we should be able to use its movement to make this thing do a series of programmed steps. For example, when we start cracking an egg, we want the scribe to be pressed into it to cut a groove. We could make a shape that pushes the cutting head into the egg when the program wheel is in the first position, then when it moves to the next position, it would release the pressure. And because the egg is also spun by the drive shaft, this would scratch the egg all the way around. This shape is called a cam, and with a bit of cleverness, we should be able to use cams to control everything. Remember that little latch to turn the hammer on and off? We can make a cam push on that to turn the hammer on after we're done scratching the egg. Then after that, we can make a cam that lifts the cutting head out of the way so it doesn't get dirty when we dump out the egg. And then the trickiest part is making it pivot the egg grippers down. Both sides have a cord that if you pull on it, twists them down. So we can attach those cords to a pivoting arm that looks like this. Engineers call this kind of thing a bell crank. But in this case, we can put a little wheel on the side of the bell crank, which can roll against a cam, which if we shape it right, we'll put the egg grippers down part way for one rotation of the crank, which will dump the egg out. And then the next rotation will rotate them further, which will trigger the eggshell ejectors. Then one more rotation and everything sets back. And putting it all together and running it does this. It presses the scribe into the egg to cut a groove, and then releases that pressure and turns on the hammer to hit the scratch and break it. Then it lifts the cutting head so it doesn't get dirty, and dumps out the egg, and then pivots the egg grippers more to trigger the ejectors, and then resets for the next egg.
Pretty crazy how much mechanical engineering it takes to replicate like 4 lines of code. It's simultaneously really complicated, but also really simple. You just turn the crank and it cracks your egg, so it's beautiful. I love it. Although it would have been a lot easier just to write 4 lines of code. But aren't you glad that I didn't? I mean, just look at this thing. It's so ridiculous. I love that this can exist. But at the same time, all the incentives are not to make stuff like this. The pressure is to make things that are simpler, more mainstream, more tuned for the algorithm. And I feel this pressure, and I'm afraid of it because I don't want it to change what I make. Like, imagine if instead of doing things that I think are cool, I was trying to do things that would perform well. All right, what's up, team? I made a money cannon. Let's go out and pretend to help people. But the pressure is real, and sometimes I wonder if the pain that I go through is worth it. Like the puzzle solving robot, it almost killed me. But one day, out of the blue, I got an email informing me that I'd won an IMI award because they really liked my puzzle robot video, which was unexpected and amazing. And of course, completely transformed my view of the puzzle robot. It's probably my favorite project now. So IMI stands for Independent Media Initiative. They're working with foundations to get nonprofit money, and then they do the legwork to find people that are creating things that they think are authentic and artistic and wonderful, and then they give them that money. They're basically creating a new set of incentives that aren't dictated by algorithms and popularity and all that kind of stuff. So thank you, IMI. I am very inspired to make more completely ridiculous things like this, and I guess we should see if it works. All right, here we go. Come on.
When you put everything together, it never works, or as I like to call it, integration hell. The program wheel's jamming up under load, but after micro-optimizing the design, I got it working. And then in the spirit of getting everything that could possibly be wrong, the hammer turned out to actually be a hole punch. But that can be fixed with a different shape and different springs. Then we had a scriber that didn't make a mark. The blade was too dull. Then we had a scriber that ripped chunks out of the egg. The blade was too sharp. Then we had a blade that was in between, and it was just right. Sorry, the kids are doing a number on me. There was a lot of other little problems, and a lot of me making this face, but eventually we got it running smoothly. Well, kind of. Remember how we made the egg grippers a lot stronger? They're so impressively strong that the egg ejectors don't work. I don't understand because I tested them when I redesigned them, but they don't work now. The reason I didn't just put a giant spring in here is that I'm extremely space constrained. So we're gonna try a different approach. Because the egg grippers are airtight, if you put air in behind the egg, it pops out. I like this because it's a surprisingly easy mod, and with air power, there's basically no limit to the egg ejection force. The trickiest part is getting air to the spinning egg holders, but since they have hollow shafts, we can just make a spinning seal on the end, and next thing you know, you got loose eggs.
I don't know what I did to my boy. This is a complete hack job, but it's gonna let us test the concept.
We've got air lines going to both the egg grippers, and pushing this syringe in will pump air behind the eggs, releasing them.
But I realized this can do something else that's really useful.
If you pull the syringe back, it vacuums the egg into the gripper.
I'm not sure if we absolutely need this, but more grip is better, especially with weird shaped eggs.
So let's see if this abomination works.
All right, so here's how I put the egg in. Push it in the one side, bring in the other side, close it, squeeze.
And if we try to pull a vacuum, it'll just pull the syringe back in. So for now, I'm just holding it back with this bolt.
Very user-friendly.
This egg is fully cracked, but the program is going to keep hammering it for 2 more rotations, which is busting up the shell and ripping chunks out. So I'm just going to lift up the cutting head for now and see how it cracks the egg.
Oh, yes! It's amazing.
Although the egg spinning is bad, that's going to break off shell pieces.
All right, now let's see if we can eject the shells. 3, 2, 1. This one come out? All right, just about. Very close. This thing can definitely work. The syringe basically did what it needs to do. I think with a bit of tuning, that'll be good. But I just don't like everything being driven from the crank. So the egg we just cracked was scored and ready to crack in like 1 or 2 rotations. But the program is just gonna keep running. So it just kept hammering and scribing it even though it didn't need it. I think we need to be able to control all the different steps independently. I think I see a way to do this without changing everything, but unfortunately it requires us to change almost everything. So I think I know what I'm gonna be doing for the next week.
I tried to keep as much of this the same as I could, but I ended up changing like 90% of the parts. But on the plus side, it was mostly water jetted or 3D printed parts, which are a lot easier to remake. A big part of my effort was making the air eject system easier to use and not crappy, which meant routing all the airlines internally, which was a huge pain and changed almost every part.
It is finally together. It's almost like a real thing. Everything is properly designed. On some level, maybe it was worth it. I don't know, probably not.
Let me show you how it works. You put the egg in just like before, then pull this back to vacuum the egg in place. And if you want to eject the egg, you press this button. But let's not get ahead of ourselves. The next thing we do is turn this knob a few times to score and crack the egg. And then instead of the program wheel, we have this little lever. And this operates all the cams. lifting up the cutting head, and pivots the egg grippers, which should not do that.
What?
Ugh, I thought we were done with this. Let's just say there are problems with the vacuum system, the egg grippers,
Oh my goodness.
and the shell ejection system.
Now, it'll probably eject this side first. And it should eject this side now.
But there's one problem that's kind of a big deal. Do you see it? Only half of the egg is coming out. This happens when one of the shells comes off first, which releases all the air pressure, and no air pressure, no eject. I saw this on the previous version, but I thought I'd be able to tune it out. Nope. A proper fix is too much work, so I just added this valve. Now if one side fails to eject, you can close off the open side and run the ejector again to get out the other shell.
I actually spent a whole day trying to make pistons that would push the shells out with little check valves in them so they could still pull a vacuum. I just couldn't make them reliable. So this is what we have for now, but I'm okay with that because this is a prototype. I know if I did another iteration of it, I could fix all these things. But right now, I just want to see the process work and prove that the concept is sound.
And it's looking pretty good, so let's see if this thing will work.
Beautiful. Oh man.
And look how clean this break is. It's like almost perfect.
All right, now it just has to eject the eggshells. All right, here we go. 3, 2, 1. Oh, that's so good. I know it's just cracking an egg, but it took so long to get here. It is so cool to see it finally doing it. And it is a bit more complicated than I was expecting, but I don't know, I just love it. With another iteration of redesigning and remaking probably every single part, we could get rid of the valve. I think we could get rid of pulling back the syringe and always eject both shells reliably. But kind of tired of redesigning and remaking stuff, so we're not gonna do that right now. What I'm curious about is what my wife thinks. I suspect she's gonna find it a little bit hard to use, but only one way to find out. All right, wife is here. She's ready to judge things. She looks like she's got her judging face on. Does this look like the future?
It looks like the stuff of future infomercials.
Okay, let's not get ahead of ourselves. Here's your egg. Put the egg in there. All right, pull that back. The egg is now suctioned in place. And give this a few cranks. See the little crack?
Ooh. Now how do we get the shells out?
Press this button. All right, there goes one.
Do I do it again?
No, pull this back out. Now turn this 90 degrees. All right, press it again. The future of egg cracking is here. Looking past the obvious things that need to be fixed, how many out of 10?
I don't see an egg cracker.
How many out of 10 would you give this?
3.
3? That's just evil.
Do I even need to explain it?
Yes, explain.
It's huge. It's complicated. It's ugly.
I think it's great. It's beautiful.
You would.
So cool.
I mean, maybe if all I had to do was turn the crank, I would try using it.
You can take that 3 and stick it right up your sleeve and get out of here.
I ain't got no sleeves. Joke's on you!
I don't know why I even brought this lady in here. 3 out of 10. I don't know. I don't agree. I'd give it at least a 5. So there's this kind of funny story. When me and my wife first got married, we went and got our first Christmas tree. And we had no ornaments, we had no lights. and I was trying to figure out how many strands of lights do I need to buy. I want to get the minimum amount because we don't have very much money. So of course I whipped out my TI-89, and with a bit of calculus, I got the length and spacing that I needed, and they fit perfectly, which was just incredible. And I just love this as a tiny little example of how useful knowledge can be, even for silly problems. But if you're trying to learn this stuff, it's a whole other story. That can be really challenging, which is why I think this video's sponsor is important. It's called Brilliant, and it solves the problem of learning really well. It does it by taking difficult subjects like programming and breaking them down into a series of small lessons, which aren't too bad to do, but they build one on top of the other. And if you do them, at some point, you can just program. It's crazy. But the secret sauce is how the lessons work. They're interactive and built around solving actual problems, like writing code, solving equations, or even designing circuits. Imagine the difference between reading about building a house and actually building a house. Brilliant's kind of like actually building a house. And there is so much useful stuff on here. There's literally thousands of lessons across math, programming, data science, regular science, AI. Although something I've heard from people is that they don't think they're smart enough to be able to learn this kind of thing, but you absolutely can. And I hope that you do. It'll make you a better thinker, better problem solver, and it'll give you a lot of joy as well. So I hope you check it out. You can actually learn for free on Brilliant. Just go to brilliant.org/stuffmadehere, scan the QR code on screen, or click the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. And that's it. Thank you, Brilliant, for sponsoring this video, and thank you for taking the time to check it out.
And that's a wrap.